Could there be whispers of life echoing from a distant world? A mere speck in the cosmos, yet a beacon of possibilities in our unending search for extraterrestrial companions? As we peer into the depths of space with our most advanced telescopes, the enigmatic exoplanet K2-18b offers a tantalizing clue: the presence of dimethyl sulfide, DMS, a chemical largely associated with the biological processes on Earth. What secrets does K2-18b hold in its atmospheric folds, and could this distant planet really be home to life? The recent observations by NASA's James Webb Space Telescope have stirred the astronomical community and all those fascinated by the prospects of alien life. Situated 124 light-years away in the constellation Leo, K2-18b orbits a red dwarf star within the habitable zone, a region around a star where conditions might be right for liquid water, an essential ingredient for life as we know it. This exoplanet's not only in the right place in its solar system, but also shows the right signs that intrigue scientists. It has an atmosphere containing DMS, methane, and carbon dioxide. The detection of DMS is particularly compelling. On Earth, this gas is primarily produced by marine phytoplankton and is a marker of biological activity. Its presence on K2-18b suggests that we might be looking at a planet where some form of life is at work. Methane and carbon dioxide further this hypothesis, as these gases on Earth are linked to biological and geological activities crucial for sustaining ecosystems. The challenge, however, is deciphering whether these gases are truly biogenic in nature or the result of other non-biological processes such as volcanic activity. This intriguing possibility arises from the technique of spectroscopy, where astronomers analyze the light from a star as it passes through a planet's atmosphere. This light carries with it the fingerprints of chemicals in the atmosphere, revealing hints about its composition. The unique mix found in K2-18b's atmosphere, including the water vapor previously identified by the Hubble Space Telescope, paints a picture of a potentially habitable world, albeit very different from our own. But what could life look like on such a world? If it exists, life on K2-18b might be radically different from the organisms we're familiar with on Earth. The environmental conditions, such as the planet's substantial atmosphere and its position close to a volatile red dwarf star, could mean that life forms have adapted to extreme conditions that would be hostile to human life. The frequent flares and high levels of radiation from its star could have driven evolutionary paths unimaginable on Earth, leading to forms of life that are perhaps more resilient to radiation and extreme climates. The presence of water vapor is another clue that piques interest. Water vapor in the atmosphere could suggest that liquid water reservoirs exist on the surface, providing environments where life could thrive. The detected greenhouse gases could also play a crucial role in maintaining a warm enough climate for water to remain liquid, despite the distant world's exposure to its temperamental star's energetic outbursts. However, it's not just about finding water or the right gases. The entire atmospheric makeup, including temperature, pressure, and chemical composition, will influence the habitability of K2-18b. Scientists are keen to understand how these factors interact to create a stable environment that could support life. The planet's classification as a mini-Neptune, significantly larger than Earth, with a likely thick and potentially oppressive atmosphere, adds another layer of complexity to the potential for life. High surface pressures and a dense atmosphere could mean that any life forms would need to be incredibly robust, possibly existing in forms that we can only begin to imagine. As we continue to gather and analyze data from K2-18b, the potential discovery of life, whether primitive or complex, would not only revolutionize our understanding of biology, but also our philosophical and ethical frameworks. The implications of discovering life, especially if it's a form vastly different from our terrestrial examples, would extend across scientific, philosophical, and cultural landscapes, challenging our notions of life and our place in the universe. Each observation and study brings us closer to answering the age-old question that has haunted human curiosity since we first looked up at the stars. Are we alone in the universe? As we delve deeper into the mysteries of K218b, we inch closer to potentially profound answers, setting the stage for future explorations that could redefine our understanding of life itself. As this journey unfolds, join us as we continue to explore the clouds of K218b, each piece of data a crucial step toward unraveling the cosmic puzzle surrounding this fascinating world. See you next time.